Good afternoon, everyone. Good afternoon. Please sit down, please. How are you all? Very good. Okay. So today, one interesting topic we'll see, that is Newton's laws of motion. Okay. What is that? Newton's laws of motion. So already you know in 9th standard and all that three laws are there. Newton's three laws. First law, second law, third law. Okay. So today we'll understand each law and we'll understand some more information about this law and some numericals we'll try to understand and some formula. Okay, what formula is coming from these laws, that one we'll try to understand. Okay. So first everyone write heading Newton's laws of motion. Write heading Newton's laws of. Okay. Now first point to write Newton's first law of motion. First law of motion. What this is saying actually already from the previous textbooks you studied already. Everybody continues to be in states of rest or state of uniform motion unless acted upon by some external force. That means suppose I am telling one object is here, mass m. Okay, mass m. If it is at rest now, for a long time it will be at rest only. Yes or no? Now suppose a mass is here, mass m. It is moving with a uniform velocity. Then for a long time it will be moving with uniform velocity if any external force is not applied to stop that. Yes or no? So that is what the first law is saying. This is what we understood already from the law of inertia. Law of inertia, what I understood now? Everything is inside this Newton's first law. So already this idea you have. So that means what you are understanding here, if an object is there, to move this object, what you need a force. That is external agency. You need a force. Force is required to move an object. Okay, yes or no? Or if an object is moving, to stop that object you need also external force or external agency or external force. So that means the first law, if I'll understand carefully and I'll see that the physical significance, okay, is given by this first law. Or right here the Newton's right here Newton's first law gives the physical significance of force. The physical significance of force. So if you'll ask which law gives physical significance of force, so remember which law it is? Newton's first law. Physical significance of force. That means to change the direction of object or to move an object or to stop an object, you need force, an external agency. So that means physical significance of force is given by this law. Okay, suppose I am telling here one object is here. Now two forces are acting. Here F1 force, here one force F2 force. Now what will happen this object? What will happen to this object? This object will move in this direction. Yes or no? In this direction it will move. Yes or no? Now you can tell, sir, here two forces are there. One F1 force which is a horizontal force, so it should have moved a horizontal direction. No, only horizontal direction. But no, actually another force also there, F2 is there. Okay, so that is acting vertical direction. That means these two independently this force are existing here. So whatever effect happening for this body when it is moving, whatever effect is happening to this body when it is moving, okay, it is moving in horizontal direction also, it is moving in vertical direction also. Why it is moving like that? Because two forces are there. One is horizontal direction, one is vertical direction. Yes or no? So that means physically or independence of both the forces coming here. Yes or no? After that motion is happening in this direction. It is not going alone in the horizontal. It is not going along vertical. Not like that. It is going combined direction. Yes or no? Because two forces are there. Though independently these two forces exist, their significance is there and they cause the motion. So that's why vertical, when it is going like this, it is traveling some horizontal distance also and traveling some vertical distance also. Okay. So remember what you understood here. The Newton's first law gives the physical significance of force. Okay. Force exists, force causes motion, force can stop the object also, force can change direction also, like that you understood from here. Or you can understand a law of inertia totally contained here in the Newton's first law. Clear idea? Okay. Now next listen. Next point listen. Second law. So this is very important. Second law, listen. What is second law? Now the rate of change of momentum of a body. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which force acts. Okay. So what they are telling here, now force is directly proportional to rate of change of momentum, or a rate of change of momentum is directly proportional to force. Like that type of talk is there too. That means something mathematically they want to say about force and momentum. Some relation they want to say in this law. So what this law gives basically a direct definition of force. What it gives? Definition of force. So mathematically if you want to write, okay, already previous classes you studied, but here little will understand in details about this law. So mathematically what I can write? Now force is directly proportional to rate of change of momentum. What do you mean by rate of change of momentum? dp by dt. Rate of change of momentum mathematically can be written as what? dp by dt. Where p is basically momentum. P is basically what? Momentum, F is force. Momentum is basically mass into velocity. Already you know this one. Momentum is mass into velocity. So I can write here force vector. Actually force is a vector, so I have direct proportional to dp by dt. Now if a directly proportional symbol I'll remove, what I'll do, say I'll add one constant here, I'll multiply one constant here, and here it will be dp by dt. Okay. And remember in physics always, when rate of change of some quantity they are telling now, d by dt you have to take. Okay. See, they did not tell rate of change of with respect to what. They did not say that. Only they told rate of change of momentum. That means dp by dt. Understand? Momentum rate change. Momentum change with respect to time. Momentum change with respect to time. That is called dp by dt. So what you are writing here? F equal to k dp by dt. Now this is one thing you are getting. Now what I'll do here? For sake of generality, I'll consider k value equal to 1. So it will become dp by dt. So f equal to nothing but it is dp by dt. So here I'll consider k value equal to 1. Tell me, no doubt is there? So what I consider here, this proportionality constant k, that value I consider what? So you can k here, k you can tell, proportionality constant. Proportionality constant. So that is nothing but k. That is nothing but k equal to 1 I consider. So I got f equal to dp by dt. So direct mathematical formula, or if you say also definition of force, is given by what? Second law of motion, Newton's second law. Okay, very important this law. Try to understand. F equal to dp by dt. Write down everyone. So simply remember, the rate of change of momentum of a body is directly proportional to the applied force. That is your second law. So F equal to dp by dt. F equal to dp by dt. This is 1, 1. K is 1, F will become dp by dt. Now from this formula, so many things we can derive. We can understand. F equal to how much I got? dp by dt. dp by dt. Yes or no? Now same what is P? Little I'll analysis here. Analysis I'll do. So star mark point I'm writing. This is already formula I have. Now tell me what is P? What is P? Mass into velocity. Now all of you listen here. One derivative rule you understand. I'll try to apply that. What I'll do here? Now here two things are there. One is mass, another is velocity. Yes or no? Two things are there. So two product is there actually, mass and velocity product. Now if d by dt mass into velocity, some product is like this one, then this thing I want to expand here. I want to expand here. What I want to expand? Now this mass I'll keep here. I'll write dB by dt plus v I'll keep here. I'll write dm by dt. Did you understand this? What is I'm writing? Did not understand, right? Did not understand. What is this? Priti? No. You my last. Uday? Not getting. Okay. Listen. What exactly it is? Now you know. In physics we studied this one. This one d by dt. What is d by dt? Differentiation. It is if df by dt I'll write. What I'll write? It is differentiation of f with respect to what? T. Time. With respect to time t. Yes or no? Now next what I'm doing? Now here I have a rule like this. So d by dt is a operator or a differentiation operator, or d by dt what I am telling it is derivative. D by dt what I am telling? Derivative or differentiation. Yes or no? All of you listen carefully. That means if you will do some input will give now, some output it will give you. Take my listen. This is like an operator, remember. Here suppose I am taking a constant 1. Then derivative of constant is nothing but what it is? 0. So like this some formula will be there regarding this derivative. Did you study derivative? No. Okay. Then you remember again, one minute again I am saying. D by dt is called basically derivative or a differentiation with respect to what? T. With respect to what? T. Clear? Now what I am telling here, if d by dt of u into v I am doing. So two physical quantity I multiplied. Okay. And that differentiation if I am taking, then what I'll write? Now first I'll keep u, I'll differentiate v. Then next I'll keep v, I'll differentiate u. Did you understand or not? This is a formula actually. Derivative formula. I told d by dt is a derivative actually, mathematically operator you can tell. Okay. So derivative operator or differentiation operator. Okay. If df by dt is written like that, I'll tell differentiation of f with respect to t. So here same thing. We have written dp by dt means differentiation of p with respect to t. Like that you can tell. Now listen here. If u into v is there, what will write? U into dv by dt plus v into du by dt. Suppose I am telling here d by dt of xy. What I'll do tell? First x I'll keep. I'll differentiate what? Y. Then some next tell. Y I'll keep. What I'll differentiate? X. Did you understand this formula? The differentiation formula. U into v method. U into v method. U I'll keep dv by dt I'll write plus v I'll keep constant, then du by dt I'll derivative I'll do. Are you clear about this? Same way here. Derivative of mass into velocity. What it is? Mass into velocity. Mass one physical quantity, velocity another quantity multiplied. That one I am writing like this. How? The m I am keeping first, differentiating v plus v I am keeping here, differentiating what? Mass. Clear? Okay. So now little you understood about derivative and this formula. This is a UV formula you applied here. You are getting like this. So this one you keep here. Now here two conditions I'll take. Case 1. Suppose my mass is constant. Suppose my mass is constant. If a mass is constant, what it implies? Now there will be no change. No change of mass with respect to t. Derivative means what? The dm by dt meaning is change of mass with respect to t. dp by dt also same meaning. Change of momentum with respect to t. That's what rate of change. So dm by dt is change of mass with respect to t. Suppose my mass is constant with respect to time. So change in mass will be what? Change 0. Change in mass is 0. Yes or no? If mass is not changing with respect to time, change in mass will be what? 0. dm by dt is 0. If dm by dt 0 is coming, now you tell here what will become f? Tell what will become f? M dv by dt. Now what I can write this one as m into dv by dt is what? A. So mass into acceleration. A means acceleration. So that means what came? Now F equal to mass times acceleration is coming when mass is constant. When mass is constant. When mass is varying, now you cannot apply this one. Okay. Mass is varying, that time you can check your formula already given. dm by dt. Your variation of mass is there. Why I became it is ma? Because here it is v into this became 0. This became 0. Then dv by dt is nothing but, or let me write here one more step. M into dv by dt that is equal to mass times acceleration. That's it. Mass times acceleration. Now this is your f. So when mass is constant, your f equal to m times a. Now case 2 you take. Case 2. What is case 2? Now here velocity is constant. Suppose particle is moving with constant velocity. Velocity constant. If velocity constant, this implies what? Tell what is dv by dt say? What is dv by dt? 0. If velocity is constant, I told no, constant derivative always 0. This one you understand meaning. This is a derivative of m with respect to t, or I can tell change in mass by change in time. As mass is not changing with respect to time, its total change with respect to time will be 0. Are you getting or not? Similarly, if velocity is not changing, it is constant, then change in velocity with respect to time, what will become? 0. If something is constant, its change will be what? 0. That means initially whatever v value, final also same v value. Then when change I'll take, change means I'll do final minus initial. Then what coming? 0. So change in velocity 0. Are you getting or not? Same way here. Derivative of a constant is 0. Derivative of constant always remember 0. Derivative of d by dt, suppose d by dt of 5. What will come answer? 0. Derivative of any constant number. Constant derivative is 0. So now what happened? If this is 0, now check here this formula. F equal to what I can write? Tell. M, this is 0 plus tell V into what? dm by dt. Now what I can write? Here M equal to V into dm by dt. Now see, this is another formula came here. That means when velocity is constant, that time mass is varying. Velocity constant, mass is varying here. Then this formula is coming here. This is dm by dt, what I'll try to write here. Okay, or you can write also magnitude wise, you can write dm by dt is nothing but force by velocity. Force by velocity. So in question now they'll give force and velocity. Force is given 300 Newton, constant velocity given 20 meter per second. So 300 by 20 is what coming? dm by dt. Okay. So now dm by dt is what? That one we'll try to understand both mathematically also, physically also. Alright, dm by dt is nothing but, it is your, tell me, the rate of change of what? What is this quantity m? Mass. So I'll write rate of change of mass. What I'll write? Rate of change of mass. Okay, dm by dt, rate of change of mass. Mass by time actually. Now here also this is called as rate of combustion. What you can tell also? Rate of combustion. What is this combustion under? Now remember, whenever one rocket is going upward direction, yes or no? So how it is going upward direction? Now some fire is coming from the below, right? Yes or no? Then it is going upward direction. Now when fire is coming below, actually what is happening here? Here you have some fuel inside rocket. That is actually burning. Yes or no? Due to that, one fire is coming here outside. Yes or no? So actually when rocket is going, so much fuel was there. When according to time, fuel is burning now, that time what is happening? The rocket mass, total mass, it is decreasing. With respect to time, what happening? Decreasing. So in that case, okay, if force given, velocity given, then dm by dt, rate of combustion you can find. Or rate of change of mass you can find. Suppose I am telling, one person is standing here. Listen all of you. Okay, it is holding one container. Okay, in that container sand particles are there, sand. Okay, now what is happening here? Sands are there, or any dust, anything you take, or liquid is there, water is there, anything you take. Now suppose this person is moving with velocity v, suppose constant velocity v, it is moving. Now here I made one hole. Here what I did? I made one hole. Then what will happen? When it is moving from here, something will fall down, right? Some water molecule or water particles or sand particles, whatever, it will fall down. As time passes, this person is going now, what is happening? Here, some particles are falling down. Yes or no? Some mass is falling down. That means when that person is moving here in this direction, what is happening here? Mass of the total system is decreasing. Mass of the total system is decreasing. That means here, this very total system mass is varying with respect to time. So that time, they may ask you, what is dm by dt here? So you have to calculate with this formula. Are you getting or not? Or I am telling where dm by dt can come. In rocket case, one example I gave. One person is holding one container. In container you have water and you have a hole in that container. Then water is falling down. Are you getting or not? So in that case, mass is changing with respect to time. So that is the reason I told this formula. You will understand what is dm by dt perfectly. Okay, clear idea? So in these situations, if dm by dt they are asking, we have to find with this formula. Most of the time in entrance and all, force given, velocity given, they'll ask directly what is rate of change of mass. Okay, as I told, force given 300, velocity given 20, then 300 by 20 is nothing but how much it is? 300 by 20, 50. Yes or no? So 15 kg per second. That means I will write here what is SI unit. So right here the SI unit of dm by dt, the SI unit of dm by dt is kg per second. What it is? Kg per second. Or you can write what? Kg second inverse. Okay. In normal case, most of the case will use F equal to ma. Our case, their mass is constant most of the time. Will not go to that much there. Most of the time we'll use F equal to ma formula, because normal condition, whatever we are doing problems here in mechanics, will do mass will be constant. Mass will be constant. Most it will be not changing with the time. But some examples I gave how mass is changing with the time. Okay, understood that? So in that case, dm by dt things situation will come. Clear all of you? Yes or no? No doubt here. Each and every term you know now. So d by dt is also called derivative or change in momentum by change in time. And this is a formula, new formula today you came to know what it is. Derivative of, if two things are in product it is there, then one thing you have to keep, another thing you have to differentiate. Then again, this one you have to keep, another one you will keep, and the next to that m you have to differentiate. Like that you have to do. Yes or no? U into V formula, I told that. U into V formula. So this is all about your Newton's second law. Little mathematically you are understand. Okay, you are getting the point in mathematical way. Clear? Note it down, please. Second law gives the definition of force. Write down. Is what? The definition of force. Newton's second law gives what? Definition of force. Newton's first law what gives? Physical significance of. But Newton's second law gives definition. So net force, you can understand basically. Force equal to nothing but H. General case I told mass is constant. So net force equal to mass times acceleration. Net force equal to what? Mass times acceleration. Force equal to mass times acceleration. Remember. And this acceleration will be in the direction of force. This acceleration will be in the direction of force. The next, right? Newton's third law of motion. This one already you know. What is this one? To every action, there is always equal and opposite reaction. Right on. For every action or to every action, there is always an equal and opposite reaction. Yes or no? What is that opposite reaction? Equal and opposite reaction. When you hit with your palm now with this board or table, yes or no? So how much hard you do that? That much pain you'll get. Yes or no? With your palm. So actually all the forces, whatever force you say in the nature, all exist in pairs. That is what we'll get from this one. Newton's third law. Newton's third law tells about basically what? Pair of the forces. Action reaction. What telling it is basically? Action reaction. It says about action reaction pair. Okay. For every action there is always equal and opposite reaction. Okay. So now try to understand. Write the definition, right? Sorry, the statement you write. What is Newton's third law of motion? Now, illustration you give. One illustration you give. Listen, suppose one object, this one. This object is A. And here one object is B. Okay. You know, in your lower classes you studied, right? Each and every object attracts each other by a force. What is that force? Gravitational force. In universe, each and every object attracts each other. Yes or no? You know that, right? That is called Newton's law of gravitation. So now see here. Here suppose these two objects are attracting each other. This is the force on A due to B. Here is the force on B due to A. Force on B due to A. Like that it is there. Okay. They are attracting each other. Now what is happening here? Now the force AB will be exactly equal magnitude as force BA. Magnitude wise they both will be equal. And listen, you can see here they both are in opposite direction. But they are in opposite direction. So what I can write? AFAB is minus of AFBA. FAB equal to minus of FBA. This one also remember. So these both are opposite direction. Now, mathematically how to write? Now give one negative sign. To give one negative sign, now then you can understand these two vectors are in opposite direction. Okay, opposite direction. So that means this force, whatever existing here force, that force is having equal magnitude, having opposite direction, and acting on two different objects. Acting on what? Two different objects. So this is what basically action reaction pair. That means from here what I am understanding, if you want to understand what is action reaction pair, what are these action reaction pair? Now first, action reaction pair is nothing but like right here, action reaction pair, two forces with equal magnitude, or have, right, direct, right, have equal magnitude, opposite direction, and act on two different objects. So you check here, FAB, FBA. FAB is force on A due to B. Meaning also understand what is FAB. Now FAB means, okay, force on A due to B. So B is applying one force on A. I told you at the beginning itself, it is attractive force on A. That is basically FAB. Similarly, FB is what? What is FB? I'll tell. Now force acting on B due to A. So these two things you remember. Action reaction pair, and what is Newton's third law? Directly. So Newton's third law what gives actually? It gives information about action reaction pair. Or I can tell Newton's third law says about forces exist in pair. So what I am telling? Newton's third law gives an idea about forces exist in pair. Any type of friction, frictional force, okay, gravitational force, normal reaction, whatever forces are there. Write some examples of action reaction pair. Examples of action reaction pair. Action reaction. What are the examples? Listen first. First, a gravitational force. Right, what? Gravitational force. Second, right? Electrostatic force. Right. Electrostatic force. Third, right? Normal reaction. This all force we are going to read. Don't worry. Normal reaction. Electrostatic force will start in 12th standard. Next, right? Tension. Friction. This also you can write. Friction. No. Now one star mark point right here. Newton's third law gives idea about what? Say action reaction pair. Now any examples you can tell third law? What are the examples everyday life? See, you are able to walk. Okay, what you are doing, how you are walking. Now while walking now, your foot you are keeping like this, yes or no? Your foot you are pressing here to the floor. Now floor is giving a normal reaction to you, then with that you are walking, yes or no? So walking, swimming. While swimming, what you are doing, you say? What you are doing? You are keeping your hand like this, right, on water, yes or no? So you are giving one action, and that reaction force, you are going up forward direction. Motion of a rocket, one rocket is going upward direction. How it is going? Now see here, rocket is there here. Now fuel is burning here, yes or no? Fuel is burning means here one downward force is coming, that is giving a normal reaction in upward direction. Okay, you know every action is equal and opposite reaction, so this is giving a thrust to go upward direction, yes or no? So that is your examples, motion of a rocket. Okay, all the examples remember. And you get pain in your hand while you are hitting to a table, yes or no? Why? Because of action reaction pair. You can check that. You beat like this, hardly you beat. Hey, don't do that much. 1 minute. Don't do that. Okay, so you'll get pain. Or you beat somewhere wall and all, or someone you are slapping when you are slapping someone. How much hard you will slap now, same slap, that pain you will get in your hand also. Okay, yes or no? That is due to action reaction pair, yes or no? Clear? Getting idea? So Newton's third law gives idea about action reaction pair. Clear? This is all about Newton's first law, second law, third law. Now what we'll do, whatever you understood, some questions we'll try to do here. Some questions we'll try to do. Please complete this. Okay. Listen. Listen one question, listen here. Suppose I am taking here, if my momentum is given like this, 2t square plus t plus 1. One momentum expression given in terms of time. What is momentum? Linear momentum. 2t square plus t plus 1. Then find force in terms of t. In terms of find force. What is force? Now listen here. Just now you understood force equal to nothing but, okay, this is given, right? Given, suppose it is given magnitude wise. Take this magnitude wise given P. So force equal to nothing but, just now you understood, it is dp by dt. Force equal to what? Dp by dt. Now if P is given like this, can I find force or not? How to find? I have to do differentiation. So little idea about differentiation you should have, all the formula and all. Okay, I think already you studied that, you check, it will be there in classroom. Now see here, instead of momentum I substitute 2t square plus t plus 1. Now what you can do here, F equal to, if differentiation I will take here, now d by dt of each term, whatever each, before plus, after plus, whatever there, I am telling it is each term. You know that, right? Now here, this each term you have to differentiate. So first you differentiate 2t square, second you differentiate t, third you differentiate 1. Now same here. What force you are getting, say? Yes. Now see here. Here this differentiation I can write like this. 2t square differentiation. 2t square differentiation, what I can write? Now 2 I can take out. T square differentiation is what? Write that. You have to write that. Now this one is nothing but it is dt by dt. Now just today starting class itself I told derivative of a constant is what? Derivative constant 0. So this will become 0. Now all of you listen. F equal to how much coming? 2 into t square derivative. Anybody remember? 2t. T square derivative is what? 2t. 2 times t. How it is coming? Now this formula remember. T to the power n derivative of t to the power n. How much it is? N into t to the power n minus 1. Yes or no? Now this, suppose I am taking here dt of t. If I take t here, what will happen? It will be dt by dt. T power is 1 here. N value is 1. So 1 into t to the power 1 minus 1, which is 1 into t power 0, which is 1, which is coming 1 basically. So dt by dt is nothing but what? You can understand dt by dt is 1. But how I did this one with this formula. This is the formula, one formula is there. If t to the power is n, this is the power. Okay. Then what will happen? It will be, for answer will be n into t to the power n minus 1. Yes or no? Now next listen. What you do? D by dt of t square you do. D by dt of t square. D by dt of t square. Now t power how much coming here? 2. Now I'll write here 2. This n value is 2 here. 2 into t to the power 2 minus 1. T to the power how much? 2 minus 1. So 2 into t to the power 1. How much coming? 2t. So t square derivative is 2. How it is coming? From this formula. Check t power n is there now. Answer is what? N into t to the power n minus 1. Similarly here t power 2 is there now. And 2 into t to the power 2 minus 1. Okay. So now 2 into t to the power 1, that is 2. T power 1 is t. Now plus dt by dt is 1. This is 0. Leave it. Now what coming here? Force tell? 4t plus 1. What coming? 4t plus 1. So this is your force. So if this unit is given in kg, momentum unit is kg meter second inverse, then force unit will be what? What is the force unit? Tell. What is the SI unit of force? Say. Newton. SI unit of force is Newton. So you are understanding here. Clear all of you? Copy. Copy. So if P is given in terms of T, then you can find what is your force. What is your force? Clear? So this is the formula for derivative. If you don't know this one, you remember here. Derivative formula I applied here. Derivative of t to the power n is this one. Similarly, dx to the power n, dx to the power dx, how much it is? N into x to the power n minus 1. Okay, but if I'll tell what is the formula for dx to the power n by dt, now that will be n into x to the power n minus 1 dx by dt. Remember that. Okay, so this is the formula actually. So you can remember all these things. If both the terms are same, your xx, then here it will not, this term will not come, last term. Your tt, last term is not coming. But if xt is there now, last term will come. All the formula of derivative formula. Understood force in terms of t? No doubt. Now one more question you do. So this is which law? F equal to dp by dt. From which law we took this one? Second law. Okay. Now based on first law, do one question. Shall I go next? Complete. Okay. Now next listen. Was completed. Next question check. Take your mass you take, otherwise 2 kg take, no, 3 kg take, 3 kg. And a mass 3 kg is this much. Find, then find, right, then find acceleration of what I think, if a force acting on a mass 3 kg is this much, then find acceleration of a mass. What is the acceleration of the mass? Tell me how to find. How to find? Direct formula according to Newton's second law. What do you not tell? According to Newton's second law, say Newton's second law, F equal to mass times acceleration. When mass is a constant, you can use this formula, F equal to ma. Now they are asking A here. So how much I'll write? F by m. Now A equal to F2i cap plus 2j cap plus k cap divided by 3 meter by second square. Are getting or not? So this is the acceleration vector. But suppose you want to find what is the magnitude of acceleration. What is the magnitude of acceleration? That time what you have to do? Magnitude of acceleration. That means you have to do F vector mod by mass. Yes or no? F vector mod by mass. Magnitude of acceleration. Now can you tell what is the magnitude of this force? Can you tell what is the magnitude of this force? Huh? Root under I cap coefficient square. Remember vector. It is given in force is given in component form. Listen. So if a vector is given in this format, then its magnitude is what? Root under 2 square plus 2 square. That means I cap coefficient square, j cap coefficient square plus k cap coefficient square. Divided by 3. Now how much coming? 4 plus 4 plus 1. How much tell? Root 9. Root 9 how much tell? 3. 3 by 3 what? So acceleration, magnitude of acceleration is how much? 1 meter by second square. But vector wise can be written like this. Okay, vector wise. But magnitude wise, if magnitude you want or any option is given like this, okay, 1, 2, 3 like that meter by second square, then you can do like this. F mod by m. F mod by m. So force given, find force magnitude, then clear ma? No doubt. Clear all of you? So you understood what is Newton's 3 laws, and based on that how questions were doing. Okay, so this F equal to ma, we understood when mass is constant we can apply this F equal to ma, then you are calculating. Okay all of you, so remember up to this. Any doubt is there? Till this any doubt, like and subscribe Lakshmi YouTube channel. All the very best.